Think about the largest distance you can truly comprehend, maybe the drive to a neighboring city, or a flight across a continent. Our minds are wired for this world, for horizons we can see, and mountains we can climb. But space plays by a different set of rules. It's a realm so vast that our familiar units of measurement, kilometers, miles, simply break down. They become like trying to measure the ocean with a teaspoon. To even begin to chart this immensity, we have to abandon our terrestrial yardsticks and adopt the one true constant of the cosmos, the speed of light. So, we created a new ruler, the light year. It's not a measure of time, but the colossal distance that a beam of light travels in a single Earth year. That's a staggering 9.46 trillion kilometers, or about 588 trillion miles. This isn't just a tool for mapping the vastness, it's our only way to look back in time and understand our place in the grand cosmic story. Let's start close to home, in our own cosmic backyard. Our nearest celestial companion, the Moon, feels almost within reach. But even at the speed of light, it's not instantaneous. A signal sent from Earth takes about 1.3 seconds to cross the void and reflect off its surface. When you look up at the Moon, you're seeing it as it was 1.3 seconds ago, a tiny, but very real delay. Now let's turn to the heart of our solar system, the Sun. That brilliant star that warms our world is 150 million kilometers away. Light, traveling at its unbreakable speed limit, takes 8 minutes and 20 seconds to make that journey. This means every sunrise you witness is already an 8-minute-old memory. If the sun were to suddenly vanish, we wouldn't know about it for over 8 minutes. We live with a constant built-in time lag to our own star. Our immediate neighborhood is already proving to be enormous. Let's send a message out to the farthest planet, the ice giant Neptune. A radio signal, which also travels at the speed of light, would take over 4 hours to reach it. 4 light hours. We're still well within the confines of our own solar system, yet a simple hello already requires the patience of an afternoon nap. But humanity has sent emissaries farther. Consider Voyager 1, our most distant probe, launched in 1977. It has crossed the boundary of the sun's influence and is now drifting through interstellar space, over 24 billion kilometers from home. To send a command to Voyager 1 takes light about 22 hours. A round-trip conversation, a simple hello, and its reply, would take nearly 2 full days. This tiny, silent craft is our first true step into the galactic ocean, and even that is just the beginning. Beyond the planets and the Kuiper Belt lies a theoretical colossal sphere of icy bodies called the Oort cloud. This is the deep freeze of our solar system, a ghostly shell of comets waiting to be nudged toward the sun. Astronomers believe this cloud may extend up to 1 or even 2 light years in every direction. Think about that. Our own solar system, the one star we call home, is itself a light-year scale object. Now let's take a true leap into the interstellar void. Who's our nearest neighbor? That would be Proxima Centauri, a small red dwarf star. It's 424 light-years away. The light we see from it tonight left on its journey over 4 years ago. If we tried to travel there at the incredible speeds of our Voyager probes, the trip would take about 75,000 years. This isn't a weekend road trip, it's a journey that would span the rise and fall of entire human civilizations. And Proxima isn't alone. It's part of a fascinating triple-star system called Alpha Centauri. To the naked eye, it appears as a single bright point of light in our southern sky. But reality is far more complex and beautiful. It's a system of 3 suns, 2 large ones like our own, locked in a gravitational dance, with tiny Proxima orbiting them from a great distance. The system as a whole is about 4.37 light-years away. Our closest stellar neighbors are a complex dynamic family. Now, prepare for another jump in scale. Let's zoom out from our local stellar neighborhood and look at our home, the Milky Way galaxy. It's a majestic barred spiral galaxy, a swirling city of stars. From one edge to the other, it measures about 100,000 light-years across. It contains hundreds of billions of stars, each a potential sun, many with their own families of planets. The 4 light-years to Proxima Centauri suddenly seems like a short walk across the street. We don't live in the bustling downtown of our galaxy. Our solar system resides in a quieter, suburban spiral arm called the Orion Arm, roughly 27,000 light-years from the supermassive black hole at the galactic center. Just as Earth orbits the Sun, our entire solar system is orbiting the core of the Milky Way. But this is an orbit of truly epic proportions. 1 galactic year. A single trip around the galaxy takes us about 230 million years to complete. The last time we were in this position, dinosaurs were just beginning to roam the Earth. For a long time, we thought our galaxy was the entire universe. But beyond the Milky Way lies the profound emptiness of intergalactic space, and across that void, we can spot our nearest major galactic neighbor, the Andromeda Galaxy. It's another spiral, even larger than our own, and it sits a staggering 2.5 million light-years away. Let that number sink in. The faint fuzzy patch of light you can see from Andromeda on a clear, dark night, that light began its journey too. 5 million years ago. It was a time when our early human ancestors, like Homo habilis, were first walking the plains of Africa. We are literally looking at a fossil of light from our own prehistory, and here's the twist. Andromeda isn't just sitting there, it's hurtling towards us. In about 4.5 billion years, our two galaxies will begin a slow, majestic, and cataclysmic collision, merging to form a new, even larger galaxy. The Milky Way and Andromeda are the two titans of our cosmic county, known as the local group. This isn't just a pair of galaxies, it's a gravitationally bound collection of over 80 galaxies, spanning a region of space roughly 10 million light-years across. Most of these are small, dwarf galaxies, orbiting the two giants like moths around a flame. Our galaxy is part of a vast, interconnected family. Now let's zoom out even further. Our local group is not an island, it's just one small part of an even grander structure, the Virgo supercluster. This is a colossal assemblage of over 100 galaxy groups and clusters, stretched across a region of space roughly 110 million light-years in diameter. At its core lies the Virgo cluster, a dense, gravitational hub containing over 1,000 galaxies. Our local group is on the outskirts of this immense cosmic metropolis, slowly being pulled toward its bustling center. But even the Virgo supercluster is just a province in a larger kingdom. In 2014, astronomers redefined our cosmic address. We live in a supercluster named Laniakea, a Hawaiian name meaning immeasurable heaven. This structure is almost incomprehensibly vast, about 520 million light-years across and containing the mass of 100 quadrillion suns. It holds around 100,000 galaxies, including our own Milky Way. And all of them, every single one, are flowing. They are moving along gravitational pathways toward a single massive basin of attraction, a mysterious region of space we call the Great Attractor. We can't see it directly because it's obscured by the dust and stars of our own galaxy, but we can measure its immense gravitational pull on everything around it. When we pull back to the largest possible scales, the universe reveals its ultimate structure. It isn't a random scattering of galaxies. It's organized into what we call the cosmic web. It looks like a gigantic, three-dimensional spider web made of light. Bright, thread-like filaments of galaxies stretch for hundreds of millions of light-years, connecting at massive, brilliant nodes where galaxy clusters are born. And in between these filaments are the great cosmic voids, unfathomably empty regions, some hundreds of millions of light-years across, where very few galaxies exist. But what is this web made of? The glowing filaments we see are just the decoration. The underlying scaffold, the structure that everything hangs on, is completely invisible. It's made of dark matter. This mysterious substance, which we can only detect through its gravitational effects, forms the skeleton of the universe. Gravity then pulls ordinary gas and dust onto these dark matter filaments. Where the web is densest, at the intersections, that gas collapses, ignites, and forms the galaxies and clusters we see today. We live on the luminous froth of a deep, dark, invisible ocean. Finally, we arrive at the edge. Not the edge of the universe itself, that may be infinite, but the edge of what we can possibly see. This is the observable universe. It's not a physical wall, but a horizon in time. Because the universe is about 13.8 billion years old, light from any object farther than 13.8 billion light-years away simply hasn't had enough time to reach us yet. We are enclosed in a sphere of visibility, with Earth at its very center. But here's one last mind-bending twist. Look-back time isn't the same as actual distance. While we see the most distant galaxies as they were over 13 billion years ago, The universe has been expanding the entire time that light was traveling to us. So, the present-day physical location of those same galaxies is now much, much farther away, an estimated 46.5 billion light-years. This means the total diameter of our observable sphere isn't 13.8 billion light-years, but a colossal 93 billion light-years. And within this sphere, astronomers estimate there are at least 2 trillion galaxies. 2 trillion. From light seconds in our backyard to the 93 billion light-year expanse of all we can see, the journey is overwhelming. The scale reframes our existence, showing us how infinitesimally small we are in the grand scheme. But it also reveals something remarkable. We are a part of this universe that has evolved the capacity to look back, to measure, and to begin to understand the infinite, all with a simple beam of light. The universe is a book, written in the language of light, and we've only just learned to read the first page. If this journey through cosmic scale fills you with the same sense of wonder that it gives us, subscribe and join our expedition. With every step we take out into the cosmos, a new layer of mystery and beauty is revealed. Keep your curiosity calibrated. The map is vast, and there is so much more to explore. Every point of light you see in the night sky is not just a destination, but a history book waiting to be read. We've just begun to draw the map.